Lesson 3 is all about graphing a line using intercepts. Lines can be written in many forms. So two of the forms that we've learned about already, y equals mx plus b, so that's slope y-intercept form, and then standard form, ax plus by plus c equals 0. So we've seen lines written in both different ways. There's another way that we might see lines written, just 2x plus y equals 6. So this doesn't really have a special name, but usually you might see the variables on the left and a constant number on the right. Equations of lines in this form are just useful for graphing purposes. So something that's important for this lesson is to notice what an x and a y-intercept are. So if we have a Cartesian plane, the x-intercept is where the line crosses the x-axis. I know most of the time we've just talked about the y-intercept because that's y equals mx plus b, and b is the y-intercept. So we've mentioned this along the y-axis, that is 6 here would be the y-intercept. But actually we often have an x-intercept as well. So when we see an equation like 2x plus y equals 6, that's not really in slope y-intercept form, it's not really in standard form, but 2x plus y equals 6 is the equation that you're given. So what we could do is we could move the 2x to the right, and we could write this in slope y-intercept form, and then we could graph it like we've learned to do already, or we can graph using intercepts. So the way that we would do that is we always want to let y equal 0 and let x equal 0. And it doesn't matter which one you do first. So if we let the y equal 0, and you should always state that that's what you're doing, that means this variable here becomes 0. So we're going to sub in a 0 for where the y is. Now, why would we even do this? So if we're looking for the x-intercept, when we look up here, the x-intercept occurs where y is 0. So if the y is a 0, whatever the x is going to be somewhere along this x-axis, and that's going to be the x-intercept. This here occurs when y equals 0. So we're going to let the y equal 0 and see what we get. So if y is 0, this term here just disappears. So we get 2x equals 6. Then we actually have to solve this like an equation. So we divide both sides by 2, and we get x equals 3. So I know that we already had a graph of that up here. There's where x equals 3. But this is how we would find that if we were just given the equation. To find the y-intercept, let x equal 0. So the reason that we let x equal 0 is because up here, if this is our x-axis and this is x is 0, if x is 0, then the line will cross the y-axis somewhere when x is 0. So if x is 0, y is 6. That's the y-intercept. So the y-intercept occurs where x is 0. So we're going to let x equal 0 because that's how we would find the y-intercept. So if we sub in a 0 here for x now and not y, then we just are left with a y in our equation. And we can actually see that, yeah, y equals 6. So what you would do with this information, y equals 6 and x equals 3, you would go to the graph, put a point at each of those spots, and connect the 2 points. And that would give you your line. So this is just a different option, but it's something that you should be aware of. That let's say you're struggling with y equals mx plus b, or you want to just double check that you did it right. This is a second option of how to graph a straight line. So example 2, we often graph lines that are in y equals mx plus b form. So if you're actually given a line that looks like y equals 2x plus 5 or whatever, and it's already in that form, I wouldn't really mess with it. I would just go ahead and go to the y-intercept and look at the slope and go up or down and to the right and graph like you've already learned how to do. If you're given an equation though that's in standard form, or in this form here, then why not use x and y intercepts? It's just a different option for you to try. So if we're going to find the x and y intercept, it doesn't matter. We could let the y equal 0 first, doesn't matter. So if y equals 0, you've got to look at this equation. Some of you are pretty good, and you'll just see that this whole term just disappears. So 2x equals 7. But for now, I'll just show you. We would sub in 0, and usually when you sub something in, you put brackets around it, equals 7. So this just disappears. So we have 2x equals 7, and you'd have to divide both sides by 2. So x equals 3.5. That's going to be okay. We just have to go 3 squares over to the right and then halfway. So there's our x-intercept. If we let the x equal 0, then we're going to find the y-intercept. So if x is 0, the x becomes 0, not the y. So we have a negative y equals 7. 2 times 0 is just 0, so negative y equals 7. But then we'd have to divide both sides by negative 1. So y equals negative 7. So if you have those 2 points, that's enough. You can connect those 2 points and you can graph your line. So there's our line, 2x minus y equals 7. Just remember that. So if you want to find the x-intercept, you let y equal 0. If you want to find the y-intercept, you let x equal 0. You let the opposite letter equal 0. Doesn't matter which one you find first. So here's an equation in standard form. So if I see this equation, I could rearrange it. I could move the 3x to the other side, the 15 to the other side. I could divide everything by negative 5. I could get my equation in y equals mx plus b form, and then I could graph it. But honestly, I think some of you might notice that let's let the x equal 0 first this time. So if x equals 0, some of you might just go, okay, this whole term's gone because 3 times 0 is 0. You can imagine that 15 comes over here, it's negative 15. Divide both sides by negative 5, so I think we're going to get 3. Like, you might be able to do this pretty quickly in your head. I'm going to show the steps because 3 times 0 is going to be 0. The y is still in my equation, so I'm subbing in a 0 where the x is. Then I would probably move this this 15 to the other side. So now it's negative. Remember, if that's negative 5y, it still is negative 5y. Divide both sides by negative 5. So y equals 3. So we can go to the y-axis and put a point at 3. Then we would let the y equal 0. And again, some of you could see that if this term was just gone, move the 15 over here, it's negative 15 divided by 3 is negative 5. And I know that I could just go to x equals negative 5. 1, 2, 3, 4, 5. But I'll show you the steps because just in case that was fast. So 3x stays there. And the 5y, instead of a y, we have a 0. Plus 15 equals 0. I have 3x, and then this term is now gone. I'm going to move my 15 to the right, so now it's negative 15. And then I still have to divide both sides by 3. So I get x equals negative 5. So once I have those 2 points, I can connect the 2 dots, and my line is done. So there's 3x minus 5y plus 15 equals 0. And then the last example, example 3, determine the slope of the line whose x-intercept is negative 4 and y-intercept is negative 6. So now we want to actually find the slope of the line. And we don't have any graph paper here, so it's not meant that you would graph it. You could graph it and then just count rise over run and you could find the slope. But if you're not given graph paper or it doesn't say to graph it, then maybe we could use our slope formula. Remember that negative 4, if that's the x-intercept, that is a point at negative 4, 0. And if negative 6 is the y-intercept, that is a point along the y-axis at 0, negative 6. So you do have 2 points, x1, y1, and x2, y2. So if you remember the slope formula, we do y2 minus y1 over x2 minus x1. And just be careful, we're doing the y's first. So negative 6 minus 0 over 0 minus negative 4. So two negatives in a row there. So I would get negative 6 over 4. And that reduced is the same thing as negative 3 over 2.